Customer Churn Prediction model created by these three authors right here. And this is an article I found while researching a little bit more on how to perform customer churn analysis. And so this will be a quick overview of the article and some of the main highlights. So after the introduction, basically the reason we study customer churn is that it's much cheaper for companies to keep the same customers than it is for them to restart and find completely new customers. It's just more work and it's more expensive. So that's why you want to study customer churn to keep the customers that you have. Now let's go straight down to this system diagram here. And this is the systems diagram, the architectural design that the authors created for this. And so I'll just walk through it a little bit because it's actually a really nice process flow for how to do customer churn analysis. So you have the initial data set that comes in, and the first chunk is you're going to prepare that data. And so they go into a little more detail later, but basically fixing some of the missing values with either imputation or dropping them out, filter down the high value customers so that we're focusing on the right area, and also tag the customer churn, like whoever's churning, because that's the label that we're going to try to predict with the ending model. Next, we move over to the exploratory data analysis, and here they're doing some basic exploration of that slightly cleaned up data to just figure out what features are important. And in this article, they spent a lot on the time features of which month customer churns happened in. Next, they go into feature engineering. So they found that it was really helpful to reduce the number of features that they're using, and that way only the most important information is actually being fed into the model later on. The next one is handling the imbalanced data set, and because there's more customers who stay than churn, the churning is actually, it's not a balanced data set. There's only a small number of customers who churn, so then you have to systematically take care of that and how you're going to make sure the model still actually learns something valuable there. Now into the model generation section. First, they scale the data so that everything's on the same scale. They do the standard train and test split. And then they also do feature reduction using principal component analysis so that they actually have a smaller data set going into the initial models to speed things up. And that way you also remove a little bit of the noise coming through as well. And then this next one is a pretty important section. So the train a variety of models. And this is one of the highlights of the paper, is that they're comparing several different models on the exact same data set. And so we'll go over to the results of that a little bit later. And then they use cross-validation to choose which model performed the best. And the very last one is the overall evaluation. So evaluate different metrics such as accuracy, precision, and recall, and doing those across all the same models so that it's a fair judgment. And then you choose the model in the end. So scrolling down through this, this is just like the implementation section where they go over a little bit more detailed code and like logical code for how they clean it and how they handle the missing variables, and then how they actually did a little bit of exploratory data analysis, model generation. Kind of already covered that in just like the quick architectural review. So now in this one is a nice graph, and this is actually a plot of the accuracy, and on the x-axis is the different validation, the cross-validation that they have. And so on the bottom here we have logistic regression, which got around an 82% accuracy, and stepping up from there, this is the k nearest neighbors, and that's right around the 89% accuracy. And then jumping all the way up to here, we have like a 97-98% accuracy with random forest. And that's one of the main outcomes of this paper, is that by comparing these on the exact same data set, they just found that random forest did really well. Here's just some of the overall stats kind of printed out nicely. So precision, recall, F1 score, and report, and based on that random forest model. And here again, a nice confusion matrix, just kind of showing how many were correctly predicted, and then in these off diagonals, which ones are incorrectly predicted. And so pretty good numbers overall. And then the last part of the conclusion is that the random forest performed better, and part of the reason for that is because it doesn't have to do, it's not purely a linear model, so it can actually realize non-linear patterns throughout the data a little bit better than some of those other models, and that's what the authors attribute some of the success to the random forest one in this case. So that's an overview of this paper, and there's also a Medium article that I wrote just to kind of quickly summarize this as well. Thank you.